Okay, this is a tutorial on the fundamental theorem of calculus. This tutorial was made by Heather, Jessica, and Sarah. To start off, the basic equation you're given is an integral from a to b of f prime of x dx will equal f of b minus f of a. You can take this equation and manipulate it to get whichever value you want. For example, if you wanted to find the final position given a velocity equation, you could take the equation and write it as such. This is the same as displacement plus the initial value equal to the final position. To demonstrate this idea, we're going to use the example of a car. If this car were driving along the road and you were to take the velocity, it would start at this position and end over here. The integral is the same as the displacement, or the area from the start to the finish. When you just do the integral, you could have the distance from here to there, which is different because you don't have this initial part. You need to add the initial to get the actual final value. Now let's work on the example. If you're given the integral from 1 to 2 of 2x dx, you'll end up with the answer of x squared such that 2 and 1, or 2 squared minus 1 squared, which equals 3. FDC is often used to find final values. This is especially important on integrals that you can't do by hand, and your calculator can't do it either. For example, the integral of the cosine of x squared dx is not, you just can't do it. You can, however, find a final position or value by taking the definite integral and adding an initial value. For example, if f prime of x equals cosine of x squared and f of 0 equals 4, we can find f of 3 or any other point along this curve. We'll use a definite integral to solve for the final value using the fundamental theorem. We'll have an integral from 0 to 3 cosine of x squared dx. As you can see, we use the final right here and the initial down here as the limits. That's very important when you're using a definite integral to solve for a final value. While we have the integral, we need to add this initial value in order to get the final value. Let's now go to our calculator to do this. Okay, now that we've used our calculator, we have our final answer right here. Let's look back at the equation we used to get this. You have the integral from 0 to 3, and if you remember, 0 was the value that we had an initial at, and the initial value at 0 was this 4 right here. We're trying to find the value of f of 3, and that is why we have the 3 as the final limit of integration up top. There you go. Let's do one more example problem to really set this concept in our heads. We're going to have a car traveling with a velocity. This velocity is going to be modeled by the tangent of t cubed. We want to find the final position when t equals 5, given the initial condition of f of 0 equal to 10. If you feel comfortable or just want to try, go ahead and try this problem on your own by pausing the video and then coming back to it once you finish. For now, I will go through it with you. We're going to take an integral from 0 up to 5, this is the initial and the final, of f prime of x, or the velocity, which in this equation is the tangent of t cubed dt, and we're then going to add the initial value given, which is 10. Once you have this written out, you can go ahead and plug it into your calculator and get the final equation. Here we have the equation we solved on our calculator, the integral from the initial point to the final point of the velocity, or f prime, plus the initial value. This will give you your final position, which is 15.0358. To wrap things up, these are a couple of things you need to remember when doing fundamental theorem of calculus problems. Don't forget to manipulate the equation to fit the problem. If you're trying to find a final value, make sure you're solving for the final. Same goes for the displacement or initial. Also, don't forget to add the initial when solving for final. This is a common mistake among students, and it changes the answer drastically. Finally, don't forget to use the initial and final values of x or t as the limits of integration. Good luck!